what we have in here, an example. This is the example which I want. Okay. This is the example where we hopefully we would like to, in this example, we'd like to utilize the rules for the, which we have developed so far for the root locus. Okay, so we have this system. Okay, what are the poles and zeros of the open loop system? What are the zeros of the open loop system? Can you tell me what's the location of the zeros of the open loop system?
-1.
S equal to -1. How about the poles?
0 and -2.
0, -2, -4, and -4. So let me, the first thing I will do, let me locate them on the S-plane. So I have one pole, 1, 0, and -1, -2, and I will have -4. Okay? Now, which part of the real axis is going to be on the locus? Any volunteer? This is a 0. Sorry. Which part of the real axis on the locus? Is this part in the locus? In here, in this area? Remember, the rule stated that the number or the part of the root locus to the left of an odd number of poles and 0. So this area must be in, because I have only one pole. Okay. How about this area? Is it on the locus in here? Is this area on the locus? Between -1 and -2?
No.
No. No. How about this area?
No.
And then we'll continue to infinity. Okay. You have echo in your system. Please just, it's not clear what you are saying. Okay. Now, how many part of the locus will go to infinity in here?
تسمعني دكتور ولا لا؟
الحين okay, yes. الحمد لله على السلامة. Okay. Now, how many part of the locus will go to infinity, or how many number of asymptote? Equal to what? How many asymptote I will have in here? Okay. We know that locus will start at a 0, at a pole, and terminate at a 0. Since I have only 1 0, so, and I have the total of 4 poles, so three of the locus must go to infinity. The number of asymptotes equal number of poles minus number of zeros, which is equal to what? 4 minus 1, which is equal to 3. So I will have 3 asymptotes. What is the intersection of the asymptote with the real axis? How do we find the intersection of the asymptote with the real axis? Shabab, you have to prepare. I don't want to just, talk to myself. I'm putting the lecture for you. I know you have exams and but at least so where will be the asymptote?
تسمعني الآن يا دكتور ولا ما تسمعني؟
أيوة الحين كويس.
تمام.
So the sigma A equal to what? We divide by 3, the summation of the poles minus summation of the zeros. So I will have -2 minus 4 and minus 4 minus 1. That will give me minus 9 over 3. It will be minus 3. So I will have my asymptotes is going to be somewhere in here. What do you think the angle of the asymptotes? Sorry, phi A1, let's say. Phi A, the angle of the asymptote equal the, in here again, the difference between the poles and 0, 180 in here, and this is 2q plus 1. If I set q 0, what will be the angle, the first angle?
Doctor,
Yes.
oh, I have a question, but why did we divide by 3?
Why I divide by what? By 3?
Yes.
Because we said number of asymptotes equal to 3. Look, you look into the, okay, you look into the difference between poles and zeros. In here,
Okay.
between poles and zeros.
We have 4 poles and 1 0.
So the difference between will be what?
3.
3, which means that I have 3 zeros at infinity, and the locus must go to infinity in 3 directions. That's basically what we are saying. So we use the 3.
I see.
3. Sigma A equals the summation of the poles minus summation of the 0 divided by the number of asymptotes. This is where I'll position my asymptote. The angle of the asymptote, this is the formula for the angle of the asymptote. Is it clear?
Yes, Doctor. And where should the asymptotes be?
It is at minus 3. So you come, where is minus 3? It is here, somewhere in here. This is the center of the asymptote. And I have the first angle will be 60. Okay. The second is going to be 180 and minus 60. If you apply the formula in here, if q equal to 0, so you'll have 180 divided by 3, which is equal to
60.
60. Then make a q equal to 1. So
Will
you'll
be
have
180.
3 go and you will have 180, isn't it?
Yes.
Then q equal to 2. Okay. It will be 300, which is minus 60, the same. Look, the asymptote, number of asymptotes, they will divide the area of the S-plane symmetrically. If I have 3, I will have 3 areas. This area, this area, this area, this area, and this area, and equally divided. If I have 2 asymptotes, I will have, I will divide it into 2. If I have 4 asymptotes, I will divide the S-plane into 4 areas. And this is the angle. Okay, so basically, okay, this is what we are going to have. 1 asymptote, 2, 3. Okay, but this is not complete. What we want to do next, we would like to, any question here before we proceed? Any question?
دكتور في اسيمتوت على السيجما على الريال اكسس على طول يعني.
The asymptote, remember, the asymptote is not part of the locus. The asymptote is a guideline. How do I approach infinity? Because look, what we are doing in here in root locus, we are doing a rough sketch. We are not getting exactly, okay? We are not solving exactly. We have certain points, are important points. We will find them, but in general, the sketch is not very accurate.
Doctor, we cannot do this for more than 1 parameter. We need only 1 parameter to vary, right?
That's correct. We are taking it. We will show you if you have more than 1 parameter, but it's mainly the theory is developed for 1 parameter, and now we are taking this parameter to go positive from 0 to infinity.
To see يعني what is the impact of this parameter.
Okay.
To see what is the impact of this parameter يعني when we will go to other modes and so on and so forth.
What do you mean?
I mean يعني the idea here the root locus will give us a clear picture of the impact of K, or what is the value of K that we are interested in
Yes.
to get the mood, to get the desired mood.
Okay. That's
So this is
that's correct. Because we would like to see if the root locus will go for certain value of K, if it will go to this side. If it go to this side, it means that my system become unstable.
yeah. And in physical systems,
And
we
also,
interpret
look, wait, one more thing. If the locus only on the real axis, it means that my system is overdamped. Z
صحيح.
be greater than 1. If I will have, if it will leave the real axis, then my system become underdamped. So, as I said, what we want to figure out now, this is not complete. What we need to see, first of all, where, look, this is K. Let me clear and let me explain a little bit. Okay, this is, we said K equal to 0. We start at a pole. We end at infinity, at 0. So I will have in here also K equal to 0. And in here, this is also K equal to 0. So now look, I have two branches. One will go to infinity. The other will come in this direction. So I have two locus. One come in this direction, one come in the opposite direction. They will reach at a point. You must leave the real axis. What is we are going to do next? Where is this point? Where does the locus leave the axis? This is one issue. The other thing, are we going to cross to the right half plane? I would like to determine where is the position of this point. As I said, the root locus is, not very accurate sketch. However, I must find this point and this point because those points are very important. For these value of K, the system become, marginal stable. If you increase it beyond, the system become maybe unstable. So what we are going to do next, we will be continuing by finding this point and this intersection. Okay?
ايش صار يا دكتور؟ We cannot see the slide.
Just one second. اعطيني شوي. اعطيني صبر يا عبد الرحمن. انت كنت at the beginning of the class you were not around. الحين
لانه كان في مشكله في الصوت عشان كذا.
اوكي. طيب. شباب اذا الله يرضى عليكم اذا تعطوني 1 second. Okay. So now, as I said, now I hope you see it.
Yes, Doctor, we can see it.
The gap between them, I have to stop one and show the other. We will go in one lecture at a time. You cannot have both lecture, you cannot show, I don't think you can be able to share both of them simultaneously. Anyway, what we want to do, as I said, I need, if I have, the previous example. Okay, this is a 0, sorry. So we'll have like this. And I will have, we said, those are the asymptotes. So part of the locus will, going this way and this way. So well, somehow the locus will go in this way. I would like to, at this point, I would like to determine those 2 points. Those 2 points are important. Those are the points where, you know, it will determine the range of stability. Remember, we said in Routh-Hurwitz, we will have in certain situation where we will have one of the rows will be full of zeros. We take the row before it and we find the auxiliary equation from that row. Okay, we will take the auxiliary equation from that row. And then we proceed. You could also do it by setting S equal to J omega, but that will be a little bit more complicated. Since we already taken this procedure, so these points will be determined from Routh-Hurwitz, from the Routh-Hurwitz test. We will come and do it by an example. Okay? Well, the other points in here, where do I leave the log? Where do I leave the real axis? Okay, so basically, if you have, okay, a pole here, let's say, and a pole here. We said K equal to 0 here and K equal to 0 here. Then this is the direction of the increase in the value of K. At certain points, I must leave the real axis. So how do I find, okay, this point? Look, remember in here, this is the increase in direction of K. So with respect to between those 2 poles, what will be K in here? Okay, what do you think K will be in here?
0.
No? If this is, we have said, it starts at K equal to 0, K equal to 0, then the...
Infinity.
What?
Infinity, maybe, Doctor.
No, not infinity.
Something in the middle.
Infinity at infinity. In here,
Yes.
you can think about it as local maximum.
Local maximum.
Value in here for K.
So we need to use the critical derivative and equate it to 0.
Not the graphical, the
Derivative, I mean.
the derivative of the characteristic equation. We for K, remember the characteristic equation, 1 plus K, let's say, G of S, okay, H of S equal to 0. So let me solve for K. So K equal to what? 1 over G of S, H of S.
Minus.
And minus. Differentiate and set it to 0.
Yes. طبعا when we differentiate with respect to S, usual differentiation يعني conventional differentiation, no problem.
Yes.
جميل. طيب دكتور الحين بس لو تذكرني الحين احنا الاسهم هذه بس ليش احنا الدايركشن في واحده من اليسار لليمين ومن اليمين لليسار؟ نسيت الفكره، ايش كانت الفكره؟
Look, this is one pole and this is another pole. The only part of the real axis, I have 2 poles in this particular example. The only part of the real axis will be what? In between in here, isn't it? Do you agree?
Yes, of course.
Okay.
من 1 ل 2 لانه احنا ناخذ الاود دائما يعني.
الأود. So between this. So K هنا ب0 و K هنا ب0.
صحيح.
So it will increase in this direction. This will increase in this direction. This will increase in this direction. The 2 arrows will approach each other and then they collide. And they have the axis. And that's why you see them in this one.
جميل يا دكتور.
Okay. Let's take an example. Okay. Let's take an example where we will,
دكتور
Yes. تفضل يا ابني. Yes, ماجد.
ممكن ترجع بس السلايد اللي قبل دقيقة بس.
Yes, this one.
دكتور في المعادلة هذه إذا حطينا k يساوي 0 حيصير عندنا 1 equal 0.
لا ما تخلي، لا كيف؟
if k is equal to 0 فيصير عندنا 1 يساوي 0.
لا ما يساوي صفر. واحد. اوكي.
This is
You
ما
said-
هو
look,
related.
look. No. Look, this is, you know, I mean, I put it in this way. K equal to 0. Okay, if K equal to 0.
Yes.
If K equal to 0, look. No, look. If K equal to 0, it means that this is equal to infinity.
Exactly. And this is will be infinity when we have poles.
Yes, pole at a 0. Pole,
Yes.
you know, I mean, at a pole. Okay. Yes.
At a pole, there will be infinity.
Exactly. No. At pole, yeah, at pole equal to infinity, but the magnitude, what will be the magnitude? What will be
خلاص 1 over infinity 0.
0? But you know what he is saying. Okay, if يعني look, this is
دكتور المشكلة ايش؟ هيصير انه بيقول 1 plus 0 في infinity equals 0.
okay. لا دقيقة عبد الرحمن. Okay, let's be specific. Suppose I have 1 plus k, okay, 1 over s plus 1 equal to 0. What we are saying, okay, k equal to what? Minus s plus 1.
Yes. يا سلام يا دكتور.
Now, بس الريمارك حق الريمارك if you have k, okay, if this is okay, if k, what did you say? السؤال wait a minute. ماجد مين اللي سأل سؤال؟
إيه أنا سألت دكتور بس استغربت بس.
If k equal to 0, okay, معناها look, this is equal to infinity. That's why we are saying, okay, that's why we are saying, remember we said, okay, yeah, remember we said yeah, if you write it, okay, if you write, let me again, let me put it in this way. Now, what we are saying, okay, okay, if k, okay, this is an equation, cross multiply, so you'll have s plus 1 equal to k. Sorry, equal to minus, sorry. Okay, plus k equal to 0. Okay? This is basically what we are saying. If k equal to 0, it means I will start at a pole of the system.
Yes.
Okay? This is basically, so it is, I mean, what your remark, you should put it in, you know, when you open up the transfer function. Okay, it is, you know,
Mathematically,
كيف?
mathematically, from a mathematical perspective, this will be 1 plus 0 multiplied by infinity. 0 multiplied by infinity, we cannot say it's 0.
Well, look, I mean,
no, so I'm just
look,
your
if you
point.
want to be on the safe side, take k whatever, very small epsilon. It will not.
إيه لا بس قصدي دكتور انه هذا ياكد كلامك انه الحين ما نقدر نشوفها من هنا، لازم نروح نرجع للاساس يعني 0 multiplied by infinity.
That's correct.
We cannot say it's not a safe assumption to say it's 0, so we need to go to the basics to find that.
Yes, but يعني الحقيقة الريمارك mathematically الريمارك حقك صحيحة يا ماجد. Okay.
إيش كذا دكتور الحين؟
كيف؟
أقول now it's clear. Thank you دكتور.
ما سمعتك كويس.
أقول واضحة دكتور.
اوكي طيب الحين okay, basically let me locate the poles on the 0. I will have one pole, sorry, 1 0 at minus 1, one pole at 0, pole at minus 2, pole at minus 3. Okay, so clearly in this area I should have a breakaway point,
Local maximum.
local maximum. How do I find this one? From the
Take
character.
the derivative of
Okay, take the characteristic equation. Okay, this is the characteristic equation. Solve for k, then differentiate and set the derivative equal to 0. So this is basically what you are going to get. I'm not going to go through the derivative because that will take time, and this is mechanical thing. You know it.
yes, yes.
Okay, so this is a third order equation.
Calculator gives you the right results.
Exactly. So what you will get how many roots in here we have?
It should be 3.
But you know, I need only one. So what you are going to get, those 3. So you have to be careful which value you select from those roots.
We have to select the real part here.
Okay, but suppose in here, okay, suppose I have one of them. This is real, and I have, let's say, 5, also real.
Of course not. It has to be real and between -3 and -2.
Exactly. You have to be within the locus. Okay. If you have such a situation, you should select the point where you will be in between.
يعني الحين دكتور at s equal to -2.47 what will happen?
What will happen? The locus start. This is going to be the critically damped.
Critically damped. So this is the point.
Yes, where it's going to be critically damped. Then beyond that point, it will go, and you have complex poles, which means that the system becomes underdamped.
بس احنا ما اخترنا الكي دكتور صح؟ يعني الحين احنا ما اخترنا الكي.
عوض from the magnitude condition, okay, you can get the K.
Which will give me the critically damped response.
-2.47.
جميل. So the idea is to find the S that will give us the critically damped.
Exactly. Okay. Look, there is certain situation. Let me clear. Okay. Suppose I have this system. I have one pole here, one pole here, 1 0 here, and 1 0 here. What do you think the locus will look like? What do you think the locus look like? It will start from here, it will come here, and then it will break. The number of poles equal number of zeros, so I don't have any part of the locus will go to infinity. It will terminate at the 0. So this will go in this direction, come in here. So in here I have breakaway, and this is break in, we call it. It will come back to the real axis. The locus will come back to the real axis. This is where at the beginning we said breakaway and break in. Okay. Now, the other thing, if I have complex conjugates, how does the locus will leave the poles? Or if I have 0, how does the locus will reach the 0? So what we will do, we assume that if this is the pole, we assume we are just above the pole, and we make straight line. And we apply the angle condition. The angle condition, angle of zeros minus the angle of poles equal to -180. So I will assume, okay, in here, from this pole to this point, I call theta d, which is unknown to me. And then I will take the contribution of this angle in here, this angle, and this angle, the 90. And apply the condition. This is known, this is known, this is known. The only unknown is theta d. When I get theta d, then I can determine, let's say, suppose I get theta d equal to 30. It means that this is my tangent or whatever. So if it's 30, it means that the locus will go in this direction. By the way, if this is 30, what will happen to this one? If this angle for this pole,
So the,
30, what will be
وين الانجل يا دكتور؟ وين
the angle?
الخطأ؟ مع
Okay, the angle. This is the assumed. Okay, let me explain. This is a pole, and this is a pole. Take a horizontal line. With respect to this horizontal line, suppose I get an angle of 30. So I will measure in this way, isn't it? So the locus will go like this.
يعني from the positive x-axis يعني the hypothetical one.
Exactly. Now, if
So
this
here
is
we have kind, yeah.
so 30, what will happen to this angle? Because of the symmetry, it will be minus 30.
Yes.
Okay. Well, this is we already we have them before. Now let's take an example which will cover all the what we have done so far. Okay. First of all, how many finite zeros I have in the open loop system? This is the open loop system.
ولا zero.
Okay. I have zero number of
Zeros is zero.
equal to 0. How about the pole? How many poles I will have?
You have 4 poles.
Okay. Now, let me locate the pole of this, the open loop system. How
You have s equals 0.
open loop system? You set this to 0, isn't it?
Yes. Yes.
So, this is the location of the pole of the system. 4 open loop poles, no open loop 0. So let me locate them. I will have one pole here, one pole at -4, and the conjugate. So, which parts of the real axis will be on the locus?
From 0 to -4.
Okay, it will go. And then after that, how many, wait, let me,
Yes.
just 1 second. Saad Al-Hajri,
Yes, doctor.
how many of the part of the locus will go to infinity?
4.
4, exactly. Thank you, great, exactly. Now I want to determine, so number of asymptote, basically, number of asymptote equal to 4.
Number of poles minus number of zeros.
Yeah, number of asymptote, no, the difference between poles and zeros. So sigma A equal to what? And the denominator will be 4. The numerator, add them. -0, -4, -4, and double 4 in here. So -4, -4, -4. I don't have any 0. So this will give me what? -12 over 4 will be
-3.
So I will be somewhere in here, let's say. This is my asymptote, location of my asymptote. What are the angles? So phi A equal to 2q plus 1 over 4 times 180. So what's the first angle will be?
Well, we have to substitute for q.
If q equal to 0,
Yes, so we have 45.
45. So this is 45. It must be symmetrical. So I must have the minus 45. Then extend this one and extend this one. You can do the calculation, but this is basically what you will have.
طبعا Q دكتور is 0 and 1
It's
صح؟
an integer. It's an integer. 0, 1, 2 until you reach the difference between the positive 0 minus 1.
minus yes. All of these are has to be يعني formula sheet
Yes.
written this information.
بس تعرف يا عبد الرحمن الاوبن بوك ما نفع يعني.
لا حول ولا قوة الا بالله. انا ترى ما كنت في بداية الدكتور اجتماع، الظاهر فات علي شيء كثير.
قلت لك بدايه الاجتماع تقول لي الصوت ما يطلع، اذا انت ما كنت موجود اصلا. anyway,
لا لا انا كنت موجود بس ما كنت اسمع.
لا شباب عبد الرحمن I have to we have 5 minutes only, so let me continue. Okay, so this is basically, those are the asymptotes. So what else we need now? The locus start at this point and this point. It must break somewhere. So I must find the breakaway, and I must find out what is the j omega x's intersection and the angle. Okay, I need 3 things. The breakaway, this point. Okay, so let me start by finding the j omega x's intersection. This is, we said, we do it from Routh-Hurwitz. So this is the characteristic equation. If this is the characteristic equation, how do we formulate the Routh-Hurwitz table?
Well, we just
So this is the Rahman, stop talking. الايكو حقك.
S4, S3, S2, S0.
Okay. So look, this is what we have. The first two from the characteristic equation, and now we calculate B1, C1. If you do calculate B1, this is B1. It will be, okay, 12 times 64 minus 128 divided by 12. This will be 53. So B1 53. I can use this one and put it in to calculate C1. I need row of zeros. So this must be equal to 0. And when that will be equal to 0, which value of k will make it 0? Which value of k make it 0?
You have to equate to 0.
Equate the numerator in here equal to 0.
Yes, so you divide by 12.
No, this will be just the numerator will make it 0.
Yes. And then you divide 53.33.
So this is basically, this is what you get. This is the value of k on the intersection. This is the value of k. We find k. Now I want to find the s. Okay. So I will come to the auxiliary equation. The auxiliary equation is going to be from this one. So b, we already have it, 53 point. So I will have 0.33 s squared plus k. K, we already find 5, 6, 68.89 equal to 0. Or this is basically what we have, which will give me the intersection.
This دكتور.
كيف؟
سؤال.
Yes.
في السلايد اللي قبل اذا سمحت دكتور، احنا ليش سوينا او نبغى نجيب C1 to be 0? Why we are interested in C1 to be 0?
Because we know if C1 equal to 0, the row, I will have full row of 0.
Yes.
That I will have an auxiliary equation. It means that I have an even poles, okay? And that will indicate that I have, an auxiliary equation in the system.
So يعني the ultimate goal here is to make the auxiliary equation or to evaluate or to assess the stability.
To find the auxiliary equation.
Find the auxiliary equation.
Look, if I have a system, okay, where let's say زي ما So it is not necessarily always we will cross the j omega axis. If you do that characteristic equation, you will never get the situation of the row of zeros. Okay, so it depends on the question.
See.
Not
I
every
see.
system become unstable for certain case. So look, this is basically, well, again, the breakaway, you just, the breakaway, we said solve for k and differentiate. And if you differentiate, this is basically what we have. So the overall, okay, the last thing, even though we are a little bit late, the last thing is this angle, the departure angle, theta d. So basically, I look into the contribution of this one, and this one. Was it
45 يا دكتور ولا
كيف؟
theta is 45.
This is 90, this is 90, and this is 45, so it will be 135. No, not 45, because you are looking for this angle.
لا بس قصدي الثيتا اللي راسمها هنا ثيتا دي المفترض تكون من اليمين لليسار صح؟ فوق
Yes.
the partial angle.
Yes. So now, if this is the situation, it means that the locus will leave in this way. And the overall picture, this is basically, if you draw the root locus. Look at this one, the 135 in here. So two part will go to the infinity and cross the j omega axis, which we did the calculation. The other will go to infinity in the other direction. Okay? We will stop in here. And we'll
So is the root locus is the most difficult part in the course?
No, it's cake. This is piece of cake with the Nyquist.
لا حول ولا قوة إلا بالله.
Okay. No, this is okay. Let me now, first of all, let me stop the recording.